Welcome. Last time we talked about the chain rule. Now we will see how to apply a combination of rules. The general principle is that if you have some expression, you start with the outermost operation, whether it be power or multiplication or division, and eventually exponentials or logarithms. Apply the rule corresponding to that operation. It will tell you the answer in terms of derivatives of the constituent parts, the factors of a product, numerator and denominator of a fraction, inside of the parenthesis or the function that's outside in case of powers, exponentials and logarithms. Now we repeat this process with those derivatives and continue till you hit the variable. Let's look at this for some simple examples involving only powers and the operations we have seen so far. In our first example, I have 1 plus x squared power 4 times 1 plus x power 4 to the power 2. The outside operation is a product, so I have to use the product rule. So, the first factor is 1 plus x squared power 4. I have to take its derivative. Its derivative involves the chain rule because it's power of an expression. So I differentiate for the exponent 4 first. That's 4 times whatever is inside to the power 3. Multiplied by the derivative of the inside, that's 2x. So now I have finished differentiating the first factor. I multiply by the second factor and then plus. I have the first factor, 1 plus x squared power 4 times derivative of the second factor. The second factor is 1 plus x power 4 quantity squared. I differentiate for the exponent 2 first. That gives me 2 times 1 plus x power 4 to the power 1. Now I must multiply it by the derivative of the inside. The inside is 1 plus x power 4. Its derivative is 0 plus 4x cubed or 4x cubed. So this is the unsimplified derivative. This is essentially what I meant a few days ago when I said once you understand the rules of differentiation, you can write down the derivative more or less as you go along immediately. So you kind of keep the rules in your head and apply them at each step. Let's look at another example, this time involving a fraction. So here the outside operation is a fraction. The numerator and denominator involve powers. So I will start by using the quotient rule. To differentiate the numerator and to differentiate the denominator, I have to use the power rule and the chain rule together. So let's start. The numerator is 1 plus x cubed power 2. So I'm going to differentiate that with respect to x. Since it's power of an expression, I start with the power rule. The exponent is 2, so I get 2 times what's inside to the power 1. I must multiply it by the derivative of the inside. The inside is 1 plus x cubed. Its derivative is 3x squared. So now I have finished differentiating the numerator. The quotient rule tells me that in the derivative, the first term in numerator is derivative of the numerator, which I've just done, times the denominator, 1 plus x squared to the power 3. Then minus the numerator times derivative of the denominator. The denominator in the original function is 1 plus x squared to the power 3. So it's power of a function, so I start with the power rule, differentiate for the power 3 first, which gives me 3 times 1 plus x squared to the power 2, multiplied by the derivative of the inside. The inside is 1 plus x squared, the derivative is 2x. I need to put this over the square of the original function's denominator. So square of 1 plus x squared quantity cubed. Okay, we'll do one final example. Of course, we can distribute the power 8 in this and then do it like the previous example. But I'm going to leave it in this form and apply the rules in the sequence needed. So now the outside operation is power 8. So I differentiate for that first. 8 times what's inside the parenthesis to the power 7 times derivative of the inside. The inside is a fraction, so I have to use the quotient rule. The numerator is x plus 1, its derivative is 1, so I get 1 times the denominator of the function I'm differentiating, namely x squared plus 1, minus the numerator x plus 1 times derivative of the denominator of the function I'm differentiating. I'm differentiating what's inside the parenthesis. The denominator is x squared, its derivative is 2x. The whole thing over denominator of the function I'm differentiating, that's x squared plus 1 to the power 2. So this finishes the derivative of the expression inside the parenthesis, and so now we are done. We will continue this by looking at slightly different ways of doing these types of problems next time.